and continue. Okay. So setup is going to be, we're going to have function z, which is function on two variables x and y. Function z, which is function on two variables. So in calculus 1, we have y equals f of x, function of one variable. Now we have function two variables. Now we want to define what the limit of function is. So we have our domain, and in that domain we have a point. Okay? So we have a domain. Okay. So in domain, we have a point. And point P is going to have coordinates A and B. Okay? So what we'll do is we'll take limit of our function f of x, y. And what we'll want is we want x and y approach that point on the domain, point with coordinates A, B. Okay. So we estimate that limit, and we'll say that limit equals to L, and that means I'll try to describe it in words what it means, but it means as following. As x, y approach, I guess, limit value of a and b in the domain, the value of function z, which equals to f of x, y, approaches value function is going to be approaching L. So when a and b, when x and y is going closer and closer toward a and b, value of function f of x, y is going to be closer and closer to L. Okay, so that's, and if that's happening, then we'll say limit value function when x, y is approaching a, b equals to. That's kind of intuitive definition, and that's more or less good for us for now. If you look at what is going on in the domain, when we're saying x and y approaching a and b, you want to be careful about what we're saying here, because we can approach it something like from below, or we can approach it from a little bit to the right. We can approach it this way, or we can approach like all kind of weird ways. Okay? So that approach, XY approach value of AB is kind of vague, very vague definition, because in a domain, on a plane, you can approach a point from different directions. Just keep that in mind. You can approach it from left, you can approach it from right, up, down, or any curvy way you like. Okay. Most of the time, we're going to be using a rule of thumb to evaluate limits. Okay. So basically, what will be that saying is basically functions are good. And by good in this sense, I mean continuous. Okay? So all the regular functions we are dealing with are basically continuous as long as we are sitting inside of a domain. So what that means, more to the detail. So we have domain, right? Now it's two-dimensional domain. And if we pick point from interior of the domain, so point P from interior of the domain. And point P will have, say, coordinates A and B. And we pick it from inside of a domain. And if we want to take limit of function f of x, y, when x, y is approaching point A and B, it's going to be equal to value of function at A and B. Again, the only catch is that the function should be defined, and we are not allowed to be on the boundary. Okay? So we don't want to stay on the boundary. We don't want to be here on the boundary. Because on the boundary, it's not going to be, all the strange things going to be happening on boundary, because if you're approaching from that side, it's going to be defined or something will be happening. And you want that number to be able to calculate. So that's why we're saying it's true. Okay. So again, the catch is functions are good for long as we're staying inside of the domain. So all our regular functions, polynomials, logs, trig functions are going to be, as long as we are staying inside of the domain, they're going to be continuous. So to take the limit, all we'll have to do is just plug in the limit value, but we have to be inside. Okay. Let me run a quick example to show what I mean. Limit as x, y approaching 1, 2, function x squared plus y squared divided by e to the x plus 3y x equals. So we'll do the same thing as we did in calculus 1 to evaluate the limits. We take the limit value and we substitute into a function. And basically we're asking the function, what is your limit? And we just substitute in the limit value. So we substitute in 1 for x, substitute in 2 for y, 1 for x, 2 for y, 1 for x. And we're going to get 5 over e to the 1, right? 1 for x. E plus 6. And that will be the limit value of the function. So for example, if I want to take limit as x, y approaching 0, 1 of 3xy minus x squared minus y over sine x plus cosine x squared minus ln of 1. That's going to be equal to, so go ahead, finish up the calculations. Okay. So 0 minus 0 minus 1 over 0 plus 1 minus 0, so final answer. Okay. Right. That's what we do if we can get the limit immediately without any difficulties. Now let's do a few examples where we might deal with difficulties, and we'll see how we can try to approach them. Limit x, y approaching 0, 0 of 2x over 3x squared plus 2y. So again, our first instinct will be substitute the limit values, and we're going to get 0 over 0, which is undefined, undetermined. It's yet to be determined. So what we'll do? We'll do a form. So we have our point with coordinates 0, 0. Right? So it's over here. Okay. Now we can approach this point, say, from horizontally, right? We can approach it horizontally. Y equals to 0 horizontally. So we're going to get limit. Now we have y is equals to 0, and as x is approaching 0, right? So let's substitute that. So we're going to get 2x divided by 3x squared. So we're going to get limit as x approaching 0, because now y disappeared. So 2 over 3x, and that rule does not exist. Because we're going to get 2 over 0 plus or 2 over 0. So it does not exist. Okay, let's try another example. Usually we'll say limit as x, y approaching 0. If it's not 0, 0, then by doing substitution, say u equals x minus 3, u equal v equals to y plus 3, we can always assume that by doing substitution, we can always make that limit value to be 0, 0. Say we have something which looks like or x squared y squared divided by x squared plus y squared. Okay. Again, we plug in limit values, we get 0 over 0, which is indeterminate, so we have to work on it. Okay, let's look one more time what is going on. 0, 0. So we can try to approach it from left and right by horizontal line. Horizontal line here is going to be y equals to 0 and x approaching 0. So that's a path. So we take limit. Okay. Because y equals to 0, we're going to get 0 on top. X squared plus 0 squared. So limit as x approaching 0, 0 over x squared, and that is 0. Okay. Let's try number 1. So let's pick now vertical path. So vertical path is going to be x equals to 0, y is approaching 0. Because we want to get toward the origin, we can go from up or from below. In both cases, we have straight line x equals to 0, and y will be approaching 0. So let's calculate what will happen in the case. We're going to substitute 0 for x. Y is y. We're going to get limit as y approaching 0, 0 over y squared equals 0. we can approach point from different, using different paths. And it's the same thing as we did in calculus 1. If your left limit and right limit in calculus 1 were not equal, limit will not exist. Same thing is happening here. If you have two paths, and along two different paths, your limit value will be different, then limit does not exist. Okay? So far, nothing is wrong because they are the same. 0 equals to 0, that's not a contradiction. So you're approaching from left and right, you get 0, from below and from above and below, you get 0, so we're still in a good shape for limit to exist. Now let's approach it from a different, because we still have at least a few more lines to approach. Let's do bisect first and third quadrant and approach by this straight line. Okay, so that's a straight line of y equals to x, and x approaching 0. So take limit y equals to x, x approaching 0. We're going to get 4x squared, y equals to x, so x squared plus x squared. We're going to get limit y equals to x, x approaching 0, 4x to 4 divided by 2x squared. Do algebra, reduce it, so we're going to get 2x squared, so limit is still equal to 0, right? So we still get to run into trouble. So that probably suggests that limit equals to 0. And let's see how we're going to process in this way to show that it actually equals to 0. So that's kind of a little bit tricky. Let me point it out how we'll address this situation. X, y, we wanted to approach 0, 0. So what we do is we switch to polar. Switch to polar. And then in polar, instead of saying x, y approaching 0, 0, in polar, the same statement will be equivalent to saying radius is approaching 0. Distance from the origin is going to be smaller and smaller and eventually 0. Because r is the distance, right? So that's what we'll do. So we kind of started with saying x approaching 0, both x and y approaching 0, right? So it's kind of a weird way. Now, instead of saying that, we'll say r is approaching 0. And theta, whatever it does, no matter where it is, as long as r is approaching 0, we guarantee that we're going to hit the origin. Okay? So that's the substitution we'll do. So we'll start with our function, limit of which we want to find, 4x squared over x squared plus y. Or x squared y squared over x squared plus y squared. The limit of this one when x, y is approaching 0, 0. We switch into polar, and we're going to write 4 r squared cosine squared theta r squared sine squared theta over r squared cosine squared theta plus r squared sine squared theta. And now we'll say r is approaching 0. We're kind of doing our substitution. So far, that's good. Limit as r approaching 0. Factor r squared on the bottom. actually, right from square one, you might have said that x squared plus y squared equals to r squared, so there was no point in doing that, right? But I kind of did not notice that. On top, we have 4 r squared cosine squared theta sine squared. R squared and r squared will be cancelled out. That equals to 1. So we're going to get limit as r approaching 0. In denominator, we have left with 1, and on top, r squared cosine squared theta sine squared. Now, if you look at this expression, that is some constant, a number. It might be 0, it might be 5, it might be something, but r squared is going to be approaching 0. So what you're going to get is 0 times cosine squared theta sine squared. And that is limit as x, y approaching 0, x, y squared plus y squared. So substituting the limit value, we get 0 over 0. So let's have a look. Approach it horizontally. X approaching 0, y equals to 0. We're going to get limit as x approaching 0, x times 0 divided by x squared plus 0 squared. So we're going to get 0. Okay, now let's do blue path. Approach it from above and below. So that is y is approaching 0, x equals to 0. So we're going to get limit as y approaching 0, x equals to 0, y 0 squared plus y squared. So we're going to get 0 over y squared, so we're going to get 0. Let's try straight line y equals to x. Y equals to x is approaching 0. Into it limit, x approaching 0, x, y equals to x squared, y equals to x. That is x squared over 2x squared, limit as x approaching 0, and that equals to 1/2. Now look at all the three answers which you've got. First two we didn't have any troubles with because we were equal. That was okay. But 0 and 1/2, they are not equal. They're not equal. Therefore, limit does not exist because you recall that we should be approaching from any path and value function should be approaching with the same limit value. Okay. So we conclude that limit does not exist. So two limits for you to give a try. Limit as x, y approaching 0, 0 of x, y plus 1 over x squared plus y squared plus 1. That's the first one. And the second, limit x, y is approaching 0, 0. And we have x squared minus 4 y squared over x squared plus 2y squared. Okay, so I'm going to give you a couple minutes to work on them. Okay, so first one equals, you're going to get 0 plus 1 over 0 plus 0 minus 1. And there is no difficulties with calculating, so I'll answer negative 1. Okay. Second one is more confusing. We're going to get 0 over 0, which means we need to do actual calculations. So again, we'll do our paths. So do paths horizontal and path vertical. Okay. So blue one going to be limit as x approaching 0 and y equals to 0. And the green one is going to be limit when y is approaching 0 and x equals to 0. Write down your expression, calculate the limits. Okay. Substitute with 0 for y, we're going to get x squared minus 0, x squared plus 0. So x squared over x squared, obviously 1. Calculate the green one now. We're going to get 0 minus 4y squared over 0 plus 2y squared. So you reduce that and you're going to get negative 2. So what is our conclusion about the limit? Look at the numbers. They're not equal. So you're approaching one way, you got number equals to 1. You're approaching the over way, you got number equals to negative 2. The numbers do not coincide. So we conclude the region limit does not exist. Because we got different answer by approaching quite different problems.